Welcome to my channel, The Geezer Talks Climate. I'm the Geezer. In this video, I want to tackle the question of where is the climate modeling data, the scenario analysis coming from, who's doing it, and basically, how are they doing it? And if you recall from the last video, if you watched it, that we spent quite a bit of time talking about this particular chart from our world and data. And just to remind everybody that we are at 1.1 degree above our pre-industrial temperature. That's the degree to which the climate has warmed. And these scenarios behind me, predict under different circumstances what the warming will be like in the future. And so we spent quite a bit of time going through the details on each of these scenarios. But here, what I want to deal with is who is gathering this data. So behind me now is a Google map, and it's showing the location of the 20, I think there's 26 or so national laboratories and research facilities that are contributing to producing and analyzing this climate data. And if you just look at zoom in on the United States alone, we have the National Oceanographic and Atmospheric Administration, different national labs, the Jet Propulsion Laboratory, Lawrence Livermore National Laboratory, and several others. And these are all funded and sponsored by the U.S. Department of Energy. But around the world, there are corresponding very high-powered laboratories and research facilities as well that are contributing to this. So that map showed the individual research facilities around the world that are contributing, and this organization, this chart shows you how they're organized and who's doing it and how long they've been doing this. So it's sponsored by the United Nations and the World Meteorological Organization, and it's called WCRP, the World Climate Research Program. And they've been doing this in various iterations since the 1980s. Really, I'd say it was in the 1970s that scientists, including Carl Sagan, began to make everybody aware of this problem associated with the emission of greenhouse gases from the burning of fossil fuels. And so this group organized and has been iterating since the 1980s. So let's zero in on this 2016 CMIP 6. And so if you get into the internet and you start looking at this, it's absolutely alphabet soup. So it's a little bit hard to understand sometimes. But CMIP is Computer Model Intercomparison programs or projects, and they just finished one and published it last year, CMIP 6, and that's the one that was distributed. So the data that I showed in that introductory chart on the predictions and what has been in front of all the world leaders is precisely this information from CMIP 6. So all of these research facilities are organized through WCRP and these working projects, the WCRPs, and that data is made available to the entire world. And in fact, I'm on at least one of the CMIP mailing lists, so I kind of stay on top of what they're planning to do. Now that we have a basic understanding of who's involved in this modeling work and how they're organized, let's talk for a moment about how they're doing it. And I mean, this is a complex analysis. I don't want to make it seem at all like it's trivial, but it's based on modeling techniques that are used throughout the world every day. I mean, this can be used for, aircraft design, just lots of different engineering applications. I've done these models myself on my laptop, but obviously this is a very complicated one. So they start with these physical models shown down here in the bottom left corner, and then what they do is they're able to divide the globe, the world, into these 3D grids, which is also a very common method of solving these kinds of problems. And so within each grid, they look at what the changes are as a function of time. So just taking a little bit deeper look at that. So basically, you've got solar radiation coming in and striking the Earth's surface. You've got radiation being emitted back away from the surface, and we'll talk more about that in the next video. But the modeling groups around the world have different specialties. I mean, some of them are more involved in, the oceanographic currents and understanding all the dynamics between the ocean and the atmosphere. Others are more involved in cloud formation. There's others that are looking at high-level satellite maps of the globe and looking at where the urban areas are, where we have deforestation, and how rapidly those rates are changing. So different eyes are looking at this in slightly different ways, but again, they're coordinating all of this dynamic model through the WCRP, and all that feeds into a set of overarching models that are predictive of what things are going to look like in the future. And that's what we talked about in the last video and at the beginning of this video. And because these predictive models are so good these days, I mean, these groups are using high-powered supercomputers where I do the model on an 8-core processor in my desktop. These supercomputers are looking at 21,000 core processors, and they get better all the time. I mean, you know what it's like powering up these data centers. So it's an evolving capability. It's a very complicated but proven technology and capability. We should have a lot of faith in, not faith, but belief in the fact that the modeling data that they're coming out with has a very high probability of being correct. Back to the report on CMIP 6 for just a moment before I close here. These are the statistical levels of certainty for each of the things happening that were reported in this CMIP 6 report that went out to all the global leaders. So virtual certainty that the upper ocean is going to acidify further, which is not good for our coral system, and that there'll be an increase in hot temperatures. It's going to get warmer. That's virtually certain. Very likely that the glaciers will continue to retreat and that the sea levels will rise. Now, if you on the left side with the medium confidence in things like drought and increased flooding, I mean, there are natural cycles too. Everything is not dictated solely by this, by the greenhouse effect from these, the emission of these gases. But what this is saying is that statistically, this stands out. This is not a natural event that's occurring. This is a man-made issue, and the degree of certainty that we have in predicting these outcomes is statistically very high. So I'll leave you with that sobering thought. Thanks again for tuning into my YouTube channel, and I hope you keep coming back because there's more detail on these topics to come, and I hope they help you. Thanks.